In question 1, we have to find the cube root of each of the following numbers by the prime factorization method. So we are given these 10 numbers, and for each number we have to prime factorize that number and find the cube root of the number. And we can do that by grouping the prime factors of each number into triplets. So let's do that, starting with part 1. In part 1, the number that we have is 64. So we will begin by prime factorizing this number. Now this number is an even number, so we will start dividing by 2. So we divide by 2 and that will give us 32. This is still even, so we divide by 2 again and that gives us 16. 16 is even again, so we divide by 2 again and that gives us 8. Still even, so we divide by 2 again, that gives us 4. We can take out another 2, that gives us 2, and then finally we take out the last 2 and that gives us 1. So this completes the prime factorization process. And therefore 64, the prime factorized form of 64 has 6 repetitions of 2. 6 repetitions of 2. So if we group the prime factors into triplets, we get one complete triplet of 2 and we get another complete triplet of 2. So we can write 64 as 2 cube into 2 cube, and therefore we can write this as 2 into 2 whole cube. And from here we can write the cube root of 64 easily. So the cube root of 64 will be this product inside the bracket, which is 2 into 2, and this is equal to 4. So the answer in part 1 is that the cube root of 64 is 4. Now let's do part 2. The number in part 2 is 512, and once again we will start by prime factorizing this number. So this number is a multiple of 2. So we divide by 2 and that gives us 256. Still even, so we take out another 2, that gives us 128. This is also even, so we divide by 2 again, that gives us 64. 64 is also even, so we divide by 2 again, gives us 32. We take out one more 2, that gives us 16. We take out one more 2, that gives us 8. And now I will continue the process here on the right side. So we had 8, and then we can take out another 2 and that gives us 4. We can take out one more 2, that gives us 2, and then finally we take out the last 2 and that gives us 1. So if we look at the prime factors we have obtained these 6 2's and these 3 2's. So a total of 9 repetitions of 2 is what we have obtained. So let's write this. So 512, the prime factorized form is 9 repetitions of 2. So in total we have 9 repetitions of 2. And if we group the prime factors into triplets, we get one complete triplet of 2, another complete triplet of 2, and a third complete triplet of 2. So we can write 512 as 2 cube into 2 cube into 2 cube, which we can write as 2 into 2 into 2 whole cube. And from here it's easy to write the cube root of 512. The cube root of 512 will be this product inside the bracket here. So this will be 2 into 2 into 2, which is equal to 8. So the cube root of 512 is equal to 8. This is the answer for part 2. Now coming to part 3, the number in part 3 is 10,648. So we will first prime factorize this number and then we will find its cube root. So this number is an even number, so we divide it by 2 and this gives us 5,324. This is still even, so we divide by 2 again, and this gives us 2,662, and this is yet again even, so we divide by 2 again, and this gives us 1,331. Now 1,331 is not a multiple of 2. It's also not a multiple of 3 because the sum of digits is not a multiple of 3. It's not a multiple of 5. It's not a multiple of 7 as well. But it is a multiple of the next prime factor, which is 11. And you can verify that. So if I take out a prime factor of 11, we will be left with 121. And 121 we know is the square of 11. So we can take out another 11 and that will give us 11, and then we take out the last 11 and that will give us 1. So this completes the prime factorization for 10,648. And let's write the prime factorized form. So we have 3 repetitions of 2 and then we have 3 repetitions of 11. So if we group the prime factors into triplets, we get 1 triplet of 2 and we get 1 triplet of 11, and therefore we can write this as 2 cube into 11 cube or 2 into 11 whole cube. And from here we can write the prime factorized form of this number easily. So the prime factorized form of 10,006, the cube root of 10,648 will be this number inside the bracket, which is 2 into 11. So 2 into 11 or 22. So the cube root of 10,648 is 22. This is the answer for part 3. Now coming to part 4, the number in part 4 is 27,000. And once again, we will prime factorize this number to find its cube root. So this number is even, so we divide by 2 and this will give us 13,500. So this is what we will obtain in the first step, 13,500. Still even, so we divide by 2 again and this will give us 6,750. This is yet again even, so we divide by 2 again and this will give us 3,375. Now this number is not even, but it is a multiple of 3. So if you divide by 3, you will obtain 1,125, and this is again a multiple of 3. So you divide by 3 again and this will give you 375, and 375 is again divisible by 3. So we divide by 3 again and this gives us 125. And now let's continue the prime factorization process on the right side. So we obtained 125, and now this is not a multiple of 3, but it is a multiple of 5. So we divide by 5 and that will give us 25, and you can divide by 5 again, that will give us 5, and finally we take out the last 5 and that will leave us with 1. So this completes the prime factorization process for 27,000, and 27,000 we see has 3 repetitions of 2, 3 repetitions of 3 and 3 repetitions of 5. So let's write this: 3 repetitions of 2 and then 3 repetitions of 3 and then 3 repetitions of 5. So if we group the prime factors into triplets, we get a complete triplet of 2, a complete triplet of 3 and a complete triplet of 5. So we can write 27,000 as 2 cube into 3 cube into 5 cube, and this can be written as 2 into 3 into 5 whole cube. And from here it's easy to write the cube root of 27,000. So the cube root of 27,000 will be this product inside the bracket, 2 into 3 into 5. So 2 into 3 into 5, and this is equal to 30. So the cube root of 27,000 is 30. This is the answer for part 4. Now let's do part 5. The number in part 5 is 15,625. And as always, we will first prime factorize this number to find its cube root. Now this number is not divisible by 2, it's not even. It's also not a multiple of 3 because the sum of its digits is not a multiple of 3. But it is divisible by 5. So we can take out a 5 and that will give us 3,125, which is again a multiple of 5. So we take out 5 again and that gives us 625. This is also a multiple of 5. So we take out 5 again and this gives us 125. 125 is also a multiple of 5. So we take out 5 again and that gives us 25. And we can take out 5 yet again. That will give us 5. And finally we can take out the last 5 and that will give us 1. So this number 15,625, it's only made up of 5s and it has 6 repetitions of 5. So let's write this. It has 6 repetitions of the prime factor 5. Alright, so if we now group the prime factors into triplets, we get one full triplet of 5 and we get another full triplet of 5. So we can write this as 5 cube into 5 cube, and this we can further write as 5 into 5 whole cube. And from here it's easy to write the cube root of this number. The cube root of 15,625, this will be equal to this product inside the bracket, 5 into 5. So 5 into 5, which is equal to 25. So in part 5, the answer is that the cube root of 15,625 is equal to 25. Now let's come to part 6. The number in part 6 is 13,824, and once again we will first prime factorize this number to find its cube root. So this is even, so we take out a prime factor of 2, and that will give us 6,912. This is even again, so we take out a 2 again, and that gives us 3,456. Even again, so we take out another 2, and that gives us 1,728. This is again even, so we take out one more 2, and this will give us 864. This is still even, so we take out another 2, and that gives us 432. And this is even again, so we take out another 2, and that gives us 216. So far we have taken out 6 2's and we are at 216. So let's continue the process here. We will further prime factorize 216. So 216 is also even, so we take out another 2, and that gives us 108. This is again even, so we take out another 2, that gives us 54. Still even, so take out one more 2, that gives us 27. Now this is not even, but it is a multiple of 3, so we take out 3, and that will give us 9. We take out another 3, that gives us 3, and finally we take out the last 3, and this will give us 1. And this completes the prime factorization process. Now on the left column we have these 6 repetitions of 2, then we have another 3 repetitions of 2, and we have 3 repetitions of 3. So in total we have 9 repetitions of 2 and 3 repetitions of 3. So let's write this. The number 13,824, it has 9 repetitions of 2. 9 repetitions of the prime factor 2, and then it has 3 repetitions of the prime factor 3. So if we group the prime factors into triplets, we have one triplet of 2, another triplet of 2, a third triplet of 2, and one triplet of 3. So we can write this as 2 cube into 2 cube into 2 cube into 3 cube, right? And this we can write as 2 into 2 into 2 into 3 whole cube. So this is how we can write the number 13,824. And from here it's easy to write the cube root. So the cube root of 13,824 will be equal to this product inside the bracket here. So this is 2 into 2 into 2 into 3, and this is equal to 24. So in part 6, the cube root of 13,824 is equal to 24. Now let's come to part 7. In part 7, we have the number 1,10,592. So once again, we will start by prime factorizing this number to find its cube root. So this number is an even number. So we take out a factor of 2. We divide this by 2, and that gives us 55,296. Still even, so we can take out another factor of 2, and that will give us 27,648, which is even yet again. So I take out another 2, and this gives us 13,824. Now the interesting thing is that this number 13,824 is exactly the same number that was there in part 6. So instead of prime factorizing it further, I will just use the prime factorized form of this number from the previous part. But if it comes up on an exam or a test, then you will have to prime factorize it fully. But for the purpose of this part, I will directly use the prime factorized form we calculated in the previous part for this number, which was 2 raised to the power 9, or 9 repetitions of 2 into 3 raised to the power 3. So 3 repetitions of 3. So the number in this part, 1,10,592, is these 3 repetitions of 2, into this number 13,824, and instead of 13,824, let's write its prime factorized form, which was 2 raised to the power 9 into 3 raised to the power 3. So in total, this number has 12 repetitions of 2 and 3 repetitions of 3. So we can write this as 2 into 2 into 2 into 2 into 3 and the whole cube of this product. This is how we can write this number, and therefore now the cube root is easy to calculate. The cube root of this number will be this product that we have inside the bracket, which is 2 into 2 into 2 into 2. So 4 repetitions of 2 into 3. So that's 16 into 3, or 48. So in part 7, the cube root of the given number is 48. Now let's do part 8. The number in part 8 is 46,656. So once again, we will start by prime factorizing this number. This number is an even number, so we take out a prime factor of 2, and that gives us 23,328. This is still even, so we take out another 2, and this gives us 11,664, which is even again, so we take out a 2 once again, and that gives us 5,832, which is still even, so we take out a 2 once again, and that gives us 2,916. So we take out a 2 again because this is even, and that gives us 1,458, and this is once again even, so we take out another 2, and this gives us 729. Now this is not even, but it is a multiple of 3, this number 729. So we prime factorize it further by dividing it by 3, and I'm going to write it on this side, on the right side. So we are going to divide 729 by 3. So that gives us 243. This is a multiple of 3 again, so we take out a 3, and that gives us 81. We can take out a 3 again to get 27. We can take out a 3 again, and that will give us 9. Take out a 3 again, and that will give us 3. And finally we take out the last 3, and this will give us 1. So this completes the prime factorization process, and we see that this number 46,656 has 6 repetitions of 2 and 6 repetitions of 3. So let's write this. So 46,656 in prime factorized form, it has these 6 repetitions of 2 and then these 6 repetitions of 3. So now we are going to group the prime factors into triplets. So we will get one triplet of 2, another triplet of 2, one triplet of 3, and another triplet of 3. So we can write this as 2 cube into 2 cube into 3 cube into 3 cube, and therefore we can write this as 2 into 2 into 3 into 3 whole cube. So this is how we can write this number, and therefore now the cube root is easy to write. The cube root of 46,656 will be equal to this product inside the bracket, which is 2 into 2 into 3 into 3, and this product is equal to 36. So the cube root in part 8 is 36. Okay, now let's come to part 9. In part 9, the number that we have is 1,75,616. This is the number that we have, and as always we will start by prime factorizing this number. and then calculate its cube root. So this number is even, so we divide it by 2, and this will give us 87,808. This is what we will get. This is still even, so we take out another 2, and that will give us 43,904. This is even again, so we take out a 2 again, and that will give us 21,952. And this is even again, so we take out a 2 once more, and that will give us 10,976, which is even again, so we take out a 2 once more, and that will give us 5,488. We can take out a 2 again, and this will give us 2,744. Now I'm going to continue the prime factorization process on the right side. So we obtained 2,744. So I'm going to take out a 2 again, and that will give us 1,372. And we take out a 2 again, that will give us 686. And we can take out a 2 once more, and this will give us 343. Now 343 is not even. It is also not a multiple of 3, and it's also not a multiple of 5, but it is a multiple of 7. So we can take out a 7, and that will give us 49. And then we can take out a 7 again, and that will give us 7. And then we take out the final 7, and this gives us 1. So this completes the prime factorization process of this number. And let's see how many repetitions of 2 and 7 we get. So we have these 6 repetitions of 2 in the first column, and then these 3 repetitions of 2. So in total we have 9 repetitions of 2, and then we have these 3 repetitions of 7. So let's write this. The number is 1,75,616, and in prime factorized form this number has 9 repetitions of 2, right? And it has 3 repetitions of 7. So now if we group the prime factors into triplets, we get one triplet of 2, another triplet of 2, a third triplet of 2, and then we have one triplet of 7. So we can write this number as 2 cube into 2 cube into 2 cube into 7 cube. And therefore we can write this as 2 into 2 into 2 into 7 whole cube. This is how we can write this number. And now the cube root is easy to write. So the cube root of this number will be this product that we have inside the bracket, which is 2 into 2 into 2 into 7. That's 8 into 7, or 56. So in part 9, the cube root of the given number is 56. Finally, we come to part 10. The number in part 10 is 91,125. So once again, we will prime factorize this number and then find its cube root. So this number is not even, but if you add the digits of this number, you will get 18. So this number is a multiple of 3. So we take out a 3, and that will give us 30,375. This is still a multiple of 3, so we can take out another 3, and that will give us 10,125. This is still a multiple of 3, so we take out a 3 again, and that will give us 3,375. We can take out a 3 again, and that will give us 1,125. And then we can take out a 3 again, and that will give us 375. And we can take out another 3, and that will give us 125. Now I'm going to continue the prime factorization process on the right side. So we have obtained the number 125, but 125 now is not a multiple of 3, but it is a multiple of 5. So we take out a 5, and that gives us 25, and then we can take out a 5 again, and that gives us 5, and finally we can take out the last 5, and that gives us 1. So in all we got 6 repetitions of 3 and then 3 repetitions of 5. So let's write this: 91,125. The prime factorized form of this number has 6 repetitions of 3 and then it has 3 repetitions of 5. So if we group the prime factors into triplets, we get one triplet of 3, we get another triplet of 3, and then we get a triplet of 5. So we can write this as 3 cube into 3 cube into 5 cube, or we can write this as 3 into 3 into 5 whole cube. And now the cube root is straightforward to write. So the cube root of 91,125 will be this number, this product that we have inside the bracket, which is 3 into 3 into 5, or 9 into 5, or 45.
To learn more about how QMath can help you
10,
crack school and board exams,
given number is
explore
45.
QMath Leap, a
With
live
this, we have
online
completed
classroom
all the 10
program
parts
run
and
by
we have
highly
completed question
experienced
number
and
1.
committed teachers.